This is a very common architecture. Even though I'm sweeping some details under the rug, I'm doing what most architectures do. I'll throw a picture at you, and it's worth 1,000 words or 1,000,000 lines of code, right? And so which 1,000 words or 1,000,000 lines of code is it really worth? And so let's look at it and talk about it a little bit. These are all the patterns kind of working together now. Is we need new types of objects in our system with values and how they're related. So we have new types of objects. Here's the legal types of values for them. And here defines the legal relationships. And this is in the knowledge level or the meta architecture side of things. When we create a real running system, the user interface will be talking and creating instances of these objects that point to what their specific types of values are and stuff like that. And that's what this is what the user domain objects are going to be. But we're going to describe their types of domain objects in this knowledge level stored in a database. And so here's the behavior. And this is what varies a lot. The behaviors, you might have different kinds of strategies or rules, ways of composing together. They may even be able to tie back into a value. Maybe there's some value typed in that affects a rule. So the rule is to calculate a value based upon some attributes that you have. Or maybe you're looking things up from a table, from a database table and reading it in, or different binary operations and composing things together. But this is the part that really varies a lot in all AOMs. Right in there. So this becomes the fuzzy part. That's why I've graded out. Is if you ask me to write you a generic black box framework for building an AOM, this part's easy. Right? I can easily do these, and there's a well-known set of known patterns that's proven. And when you look at all adaptive object models, which I'm going to show you an example of 4 or 5 here in a second, you'll see this common structure. It might vary a little bit, and sometimes you might want to have inheritance in your objects, right? So you have this composite relationship, so you can have inheritance and look up the inheritance. Usually you don't want multiple inheritance because that can become confusing, right? But sometimes you might. People in C++ might be used to it, so they want to add that in. And even your types of relationships might want to have some inheritance or rules associated, so there might be some things going on there. So that's why we're using kind of the composite pattern here to build things. And you might also want to build more complex objects so we can compose them. But this is very common. This part, you'll see some common themes here. But as you see, look at what I'm going to show you on the examples. This part it will vary quite a bit depending upon systems. So here's the core architecture style of an AOM with me sweeping a lot of the details under the rug, a lot of the complexities, the business rules and stuff. But this type of structure, when you start looking at a lot of these object models or people that's built these systems, either in research or industry, successfully deployed in production systems, you see come up over and over again.